All right, so here's how we're going to do a conservation of energy problem, okay? A 75 kilogram skier is standing at the top of a 25-meter hill. What would his speed be at the bottom of the hill? Okay, assume no energy dissipated by friction. Okay, so that means no thermal. So E thermal equals 0. Okay, so you're going to make some kind of a sketch. Okay, so he's probably up here at position A and down here at position B. All right. And then we have to see what energies that we have, okay? So a 75 kilogram skier is standing at the top of the hill, and that's all we get, okay? So is he above the ground? Yep. Moving? Nope. So that's a 0. Spring stretched or compressed? Nope. So that's a 0. Okay, and the thermal energy is always 0 in the first one, right? So see in the graph, like it doesn't even include it. Okay, so it's always going to be 0. Okay. All right, so that's at top of hill. Position B is at bottom of hill. Bottom. Okay, all right, so all we have is EG, okay? So then we want to do EG equals MGH, all right? And we have the mass, which is 75 kilograms, the G, which is 10, and the H, which is 25 meters. Okay, so I'm going to have the EG is going to be 75 times 10 times 25. So that's 18,750 joules. Okay, so that's going to be your total energy, right? Because there's nothing else, so that's it. So once you get the total, transfer it to here, 18,750 joules. Okay, so now let's look at the bottom of the hill, all right? Is it above the ground? Nope, because it's on the ground. Moving? Yep. Springs? Nope. Thermal? No, because it said no, okay? All right, so then this is also 0, so all we're going to have is EK. So that's going to be dead pencil. All right, so your EK is going to be 1/2 mv squared. Plug this in. All right, so then let's see if I can get some pencil energy. Okay, 1/2 mv squared. All right, and I'm solving for the velocity, okay? So if I isolate this around, okay, you can do it in as many steps as you need to, okay? So that's 2EK over M, all right? So V equals 2 times, how much kinetic energy is there going to be? Well, there has to be 18,750, right? Because that's the total. Where's my thing at? Where's the little thing at? Oh, down here. Why did I get down there? Okay, so if that's 18,750, right, and there's nothing else, then that has to be 18,750. There's no other choice, okay? Divided by the mass, which was 75 kilograms, okay? And then that's going to equal times 2 divided by 75, and then square root that is going to be 22.3 meters per second. So that's going to be right there. Okay, all right, and then if I want to graph it, this one's pretty easy, so I'm just going to choose a random place to be 18,750 because that's all I really need is that one value. Okay, so there's no gravitational, there's going to be that much kinetic, and no EE. Okay, and then in the after, oh, no, that's not even right. Boop, 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 boop. Oops. Erase, that's not even right. It's going to be gravitational in the beginning. That's 0, okay? And then by position B, no gravitational, no elastic, no thermal. It's going to be all kinetic. Boom. Okay? There we go.